Trig identities. We did some in the last video, like some of the reciprocal and quotient identities, and we got some double angle and half angle and Pythagorean identities for this video. Okay, sine of 2a, these are on your formula sheet. There's only one choice for sine of a double angle. Cosine of a double angle, you got to kind of make a choice, and you'll see later on where that's going to be kind of important. All right, half angle. Again, these are provided for you for sine, cosine, and tangent of a half angle, and they're on your formula sheet. The key to being able to evaluate those is knowing what the cosine of the whole angle is, cosine A. Okay? All right, so down here, let's see what we got. Right, as a single trig function. So this is what I want to do. See, when I have a question like this and I see sine 2x in there, what I want to do is I want to kind of replace it with what that's equal to, which is 2 sine x cosine x. 2 sine x, cosine x, over 2 cosine x. And hopefully you'll see, it's kind of readily apparent here that the 2's will cancel, the cosine x will cancel, and this will simplify to just plain old sine x. Okay? There we go. Well, you can use these identities to simplify trig expressions or help you solve trig equations. Either one. Okay. Cosine x equals a half, find sine half x. If cosine x equals a half, find sine half x. So if I'm trying to find sine half x, I'm going to be using this formula, which is right here. 1 minus the cosine of A. 1 minus the cosine of A, which is 2, all over 2. Okay, and then what I told you to do with these kind of complex fractions here is take and multiply every single one of these terms by 2. So we're going to multiply that by 2, that by 2, and that by 2. So what I get is plus or minus the square root of 2 minus 1 over 4, which equals plus or minus the square root of 1 over the square root of 4, which is plus or minus 1. There we go. Okay. Next, sine x, secant x, cotangent x. The key to this is trying to write these all in terms of sine and cosine. Well, this one already is sine x, so I keep the sine x. And then times. Secant x is 1 over the cosine of x. And then cotangent x, now that's 1 over the tangent. But I told you, right, I think it's a better idea to try and write it in terms of sine and cosine. So we'll use the quotient identity, cotangent x equals cosine x over sine x. And then you'll see how this is a nice problem here. Everything kind of just cancels each other out because this guy's over 1. That's really in the numerator. So everything cancels, so the answer is 1. There we go. Pythagorean identities. Now these are not given to you on the Regents, okay? And if you are going to memorize just, let's say you can only bear to memorize like one thing, well, memorize this one. All right, because I've shown you in class a couple times how to take and derive the other two from that one. And then more importantly, these over here, okay? These over here are going to be very helpful. If I have like a cosine squared in an expression, I can take it out, put it in 1 minus sine squared. So that might be handy if I'm trying to get everything written in terms of one trig expression. Word of caution here. Okay, the cosine of A doesn't equal to 1 minus the sine of A. Remember, this comes from the Pythagorean theorem. They have to be squared. So I've seen that a lot of times. Don't do it. Okay, you can't change cosine to 1 minus sine. You can change cosine squared to 1 minus sine squared. Okay, so we're going to verify the following trig identity. And when you're verifying a trig identity, remember, you can't assume equality. You have to prove equality here. So there's not going to be any multiply both sides by the same thing or move things to the other side. Everything that's kind of on this side needs to stay on this side, and everything on the left needs to stay on the left, and everything on the right needs to stay on the right. So what I can do here is I can take and rewrite this. Secant x, okay, well, that's 1 over the cosine. That's usually a good idea to start. Is that always going to work? No, but it's not a bad place to start. And then 1 minus sine squared, you can see right here, is equal to the cosine squared. And then that's really over 1. And then I can go ahead and I can cancel a cosine x from each term. And I wind up with cosine x. And once I get that worked down to a certain point, I can't really do anymore. I look at the other side and, oh, I'm already done. So I picked a relatively short one here for the purposes of the video. Yeah, I think you just basically get the gist. All right? All right, moving on to trig equations. All right, when you're solving trig equations, you want to find all values on the given interval that make the equation true. All right, and then we're going to find the reference angle first, and then use all-star trig class, determine what quadrant it could possibly be in, and then use that reference angle to come up with the actual angle x or theta, whichever it is. All right, so some hints. All right, it's a nice idea if you can write it in terms of one trig function. Okay, and that's really kind of key. If you can do that, then you can solve for that one trig function and use like inverse trig functions or arc trig functions to find the angle, the reference angle. If it's linear, you want to get that trig function alone. Okay. If it's quadratic, a good hint is to let a equal whatever the trig function is, like a equals sine x or a equals cosine x, and then solve for a, like a normal quadratic. Then once you have all the possible answers for a, you can put the trig function back in, and you'll see that in the quadratic example I have. All right, so we'll start here. First of all, is this a linear or quadratic equation, this example? 2 sine x equals 1. That's linear, right? I mean, it doesn't have anything squared, okay? So 2 sine x equals 1. So if this is a linear, it's already written in terms of one trig function. What I'll do is I'll try and get my trig function alone by dividing both sides by 2. So I get sine x equals a half, okay? And then I know my reference angle, alpha, is going to equal the arc sine of a half, all right? And make sure it's like the absolute value. If this had been a negative, I still want to do it as the positive function, okay? Now some of you may know where the sine is equal to a half from your special triangles. Let's say you don't, right? I mean, it's not the end of the world. You can do arc sine 1/2, then it will give you the reference angle of 30. So once I know alpha is 30, that's my reference angle. Now I'm going to look at the interval I'm given and come up with all the possible answers, okay? So it's 0 to 360. Notice here that my sine x was positive, okay? Sine x equal to positive half. So I'm going to be looking where the sign is positive, okay? And it's positive here in the first quadrant and in the second quadrant. So what I need is then I need like a reference triangle in each one of those quadrants. And I put my reference angle in here, 30, okay? And in the first quadrant, the x or the theta does equal, it just absolutely equals it. So my first answer is x equals 30, okay? In the second quadrant, if I draw an angle in standard position in the second quadrant with a 30-degree reference angle, remember reference triangles are always drawn to the x-axis. Now I can figure out what the actual angle x is. This is actually x, okay? Well, all the way from here to here is 180, remember? So if that's a 30-degree angle right there, then this one is 180 minus 30, or 150 degrees. Okay? That's kind of how a linear function works. Now, if this had been, for example, negative 1/2, then I wouldn't be looking in the first and second quadrant. I'd be drawing reference triangles in the third and fourth. Okay. Solve sine squared plus 4 sine theta plus 4 equals 1. Okay, so look, this is a quadratic. I've got a sine squared there, right? And the other one is in terms of sine as well. So what I'm going to do here in this case is let a equal the sine of theta. And then rewrite it using a's. A squared plus 4a plus 4 equals 1. And then you solve this just like you would any normal trig function. All right, quadratic function. I subtract 1 from both sides, just like that. And then hopefully it factors. A plus plus. If it doesn't, you could use like the quadratic formula or completing the square. Okay, either one of those. And we'll be going over those later in another video. I think that works. 3 times 1 is 3, 3 plus 1 is 4, and both signs are positive. So I'm getting a equals negative 3, and I'm getting a equals negative 1. Okay, so those are my two possibilities. So I know now it's time to go back and take my a's out. That was just something that we invented, right? And then try and solve this, all right? Well, sine theta equals negative 3 right here. Well, you got to remember what the sine curve looks like. It goes from 0 up to 1, down to negative 1, 0, negative 1, back to 0. And negative 3 is like way down here. Okay, this is never going to happen. Okay, so if you have sine theta equal to something like greater than 1 or less than negative 1, you're not going to have any solutions from that part of the problem. This other one here, sine theta equals -1, I'm not going to use reference angles here. This is the exception to the rule, right? When I have sine or cosine equal to -1, 0, or 1, I'm going to use the unit circle. So I don't use reference triangles in this case, all right? So just keep that kind of trick in mind there. Makes your life easier. 1, 0, 0, 1, -1, 0, and 0, -1. Okay, so I want to know when the sine is equal to -1 from 0 to 360. Okay, well, that happens like right here at this value right here, right? So what kind of angle is that? That is a, let's see, this is 90, 180, 270, 270 degree angle. So I only have one solution there. Okay. Next, solve cosine 2x plus cosine x equals 0 from 0 is less than or equal to x is less than or equal to 2 pi. All right, now I really prefer to work with degrees, so I'm going to take this and just right away kind of convert that to degrees. The pi's will cancel, and I'm going to get 360 degrees. Now, this is fine while I'm working, okay, but just remember your final answer has to agree with the units that they give you, so my answer needs to be in radians, probably in terms of pi, okay? And remember, pi is not a unit for radians, it's just it's a value, okay? 3.14159, all right? Cosine 2x plus cosine x, okay? Cosine 2x plus cosine x. Now is where I was talking about all those different possibilities for a cosine of a double angle. And let's go back and look at them really quick. All right? I could either have this one that's got a cosine and a sine in it, this one that has just a cosine, and this one that has just a sine. Now, since I'm going to look at what I have in the rest of the problem and try and match it. Okay? Oh, see, I've got the cosine of the double angle, and then I've got this cosine right here. So I'm going to want to pick the one that has just a cosine in it. All right, and that is going to be the second one, 2 cosine squared a minus 1. So I'm going to go with 2 cosine squared a minus 1. So this part right here is 2 cosine squared x minus 1, and then plus cosine x, and then that equals 0. So that part right there is that part. You know, I only put that in parentheses so you can see that's what the substitution is, okay? Okay, so now I have a cosine squared, so I'm going to try my let a equal cosine x this time. Okay, let a equal cosine x, and then I get 2a squared minus 1 plus a equals 0. I'm going to write this in order, 2a squared plus a minus 1 equals 0, and then I'm going to try and factor this guy. So it's going to be 2a and a equals 0. I want this to be a plus 1 and a minus 1 because then I do outers and inners. That will multiply, that will add up to give me plus a. Okay, so there it is. So 2a minus 1 equals 0, a plus 1 equals 0. Here I'm going to get a equals positive 1/2. Here I get a equals negative 1. Now it's time to take those out and put this back in. Cosine x equals 1/2. And cosine x equals negative 1. This guy right here comes right from my unit circle. What values does cosine x equal negative 1? That's 180 degrees. So this one is 180 degrees, which when I convert actually turns into pi. Cosine x equals 1/2. That's alpha equals the arc cosine of 1/2. All right, when I take the arc cosine of 1/2, I am going to get 60 degrees. And I did that from my reference, from my 30, 60, 90 triangle. Okay, and you can also use your calculator. Now, this is cosine positive, right? So I got to go back to my all-star trig class here and find out what quadrants I'm going to get answers from. I'm going to get something from the first quadrant, where I have a 60. So my x equals 60. And something also from the fourth quadrant. Okay, so down here in the fourth quadrant with a 60-degree reference angle, this guy is 300. So I get 60 and I get 300. Okay, now 60, when you convert that, turns into pi over 3, and this guy turns into 5 pi over 3. Don't forget to convert them back to terms of pi. Okay, thanks.